Welcome back to This Week in Biochar, where we take a deep dive into the latest biochar news and research.
I'm excited to jump in and see what caught the eye of Biochar Today readers this week.
First up, we've got a blog post straight from Biochar Today. It's titled, A Scientific and Economic Blueprint for Biochar Project Success.
Oh, interesting.
Yeah, it was published March 3rd, 2025, so just this week. And, it tackles the big question of why some biochar projects are so successful and some just fall flat.
Right, because biochar has so much potential, right, for cleanup, even in industry.
Absolutely, but we've seen so many projects struggle.
For sure. So what are the keys to success? What did this blueprint say?
Well, they highlighted three main things: feedstock technology and demand.
Okay, that makes sense.
And they really emphasize that it's not just about finding a sustainable feedstock,
Right.
has to be readily available too.
Yeah, what works in one place might be a logistical nightmare somewhere else.
Context,
And then there's technology.
Right.
Because the type of system you use, from those simple kilns to the super high-tech pyrolysis systems,
Yeah.
that really impacts the biochar's properties and the project's economics.
Like using the right tool for the job.
Yeah, exactly. It's like the hammer's great for nails, not so much for screws.
Makes sense.
And then finally, there's demand.
Oh, that's crucial.
You can make the best biochar in the world,
Right.
but if nobody's buying, it's pointless.
It's true.
You got to understand the market and what people actually need.
Totally. If you open a restaurant but nobody likes the food, you're not
Yep.
going to stay open for long.
Exactly. And this blog post is really honest about the challenges, too.
Like what kind of challenges?
They talk about funding, actually scaling production to meet demand,
Right.
competing with cheaper alternatives,
Mm-hmm.
raising public awareness. Yeah, those are all big hurdles.
They are, but it's good to acknowledge them.
For sure.
Okay, so moving on from the blueprint for success, let's look at a scientific article that focuses on a very specific application of biochar, removing PFAS,
Ah, those forever chemicals.
the ones that are everywhere and so hard to get rid of.
It's a huge problem, and finding ways to remove them is critical.
Absolutely. So this article is still under review, but it takes a deep dive into how biochar can tackle PFAS contamination.
I'm really interested to hear this.
Yeah, me too. So they start by breaking down how biochar's properties
Like its structure and porosity.
exactly make it effective for PFAS removal.
It's not just about trapping the chemicals, right? It's about how they interact with the biochar's surface.
Right, and they talk about all these different ways to analyze the biochar, like BAE analysis.
Oh, right, to measure surface area and pore volume.
And EDX to figure out the elemental composition, things like the OC ratio.
Yeah, that's important for understanding things like carbonization and how hydrophobic the biochar is.
Exactly. And then there's TGA, which shows how the biochar breaks down at different temperatures.
So we can see how it'll behave long term.
Right, and here's where it gets really cool. They talk about functionalization.
Oh, so tweaking the biochar to boost its PFAS removal.
Yeah, exactly. And they go through all these different methods.
Like magnetization. I've heard about that.
Yeah, that's where you add iron oxides to the biochar, making it magnetic so you can just pull it out after it's done its job.
Wow. So it's like using a magnet to pick up spilled paper clips, but on a much tinier scale.
Exactly. And then there's nanoparticle impregnation, steam activation, chemical modification, all sorts of ways to fine-tune the biochar.
So we can really target those PFAS molecules.
Yeah. But even with all these amazing techniques, there are still factors that affect how well it works.
Like what?
They mentioned pH, the length of the PFAS chains, even the presence of other contaminants.
Right. It's a complex system.
It is. And of course, the article acknowledges that we still need more research,
Of course.
especially on removing those really short-chain PFAS.
Yeah, those are tricky.
And then there are questions about standardizing production methods and making sure these modifications don't cause any unintended environmental problem.
Right. We want to make sure we're solving one problem without creating another.
Exactly. So for our last source this week, we're going to move beyond powdered biochar and into the world of 3D materials. Biochar-hydrogel combos.
Oh, cool. Like a hybrid material.
Exactly. A scientific review in the journal Processes explored this new frontier.
That sounds fascinating. Biochar and hydrogels, what a combo.
Right. So they say these composites have the best of both worlds.
What do you mean?
Well, biochar brings its high surface area and porosity to the table,
Right.
and the hydrogel adds its 3D network structure.
Uh-huh.
So they say it leads to even better absorption and makes the material easier to handle.
Oh, interesting.
And they talk about two main ways to make these composites: encapsulation and copyrolysis.
What's the difference?
So encapsulation is kind of like trapping the biochar particles within the hydrogel matrix.
Like suspending fruit in jelly.
Exactly. And copyrolysis is more like forming the biochar directly from a gel precursor using high temperatures.
So it's like baking a cake where the ingredients are all mixed together.
Yeah, and they say these composites can be used to remove all sorts of things from water.
Like what?
Organic pollutants like pharmaceuticals and pesticides, heavy metals like lead and cadmium, even excess nitrogen and phosphorus.
Wow. So many
I
applications.
know, it's impressive. And they don't just say it works. They actually explain the different mechanisms
The
involved.
whole, like, the nitty-gritty of how the pollutants are actually removed.
Exactly. You've got adsorption ion exchange, complexation, precipitation.
Mm.
It's a whole symphony of removal techniques.
That's so cool.
It is. So that wraps up our whirlwind tour of biochar news from Biochar Today this week.
It's incredible to see so much happening in the world of biochar.
Right, from project blueprints to PFAS removal and those innovative biochar hydrogel composites.
The future of biochar is bright.
It is. It's one thing to know that it works, but understanding how it works takes it to a whole new level.
Absolutely. So let's start with the most basic mechanism, adsorption.
Okay.
This is where those pollutants actually bind to the surface of the biochar, you know?
Like it's trapping them.
Exactly. And biochar is so good at it because it's got all those pores and that huge surface area. So there's tons of space for those pollutants to grab onto.
Like a super sponge.
Right. And then you've got ion exchange.
Which is?
Well, imagine that sponge has tiny magnets in it.
Okay.
So it's not just about physical trapping now. It can also swap ions with the surrounding water.
So it can pull out specific contaminants based on their charge.
Exactly like a bouncer at a club, only letting certain ions in.
I like that analogy.
And then there's complexation, where the biochar actually forms strong bonds with the contaminants, making them harmless.
Like putting them in handcuffs.
Exactly. They're neutralized. And then finally, you've got precipitation.
Okay.
This is where the biochar helps transform the contaminants into something that can easily be filtered out.
Like turning a murky pond into clear water.
Right. The sediment just settles to the bottom.
So it's not just one thing, it's this whole combination of mechanisms working together.
Exactly. A multi-pronged attack on those pollutants. And the more we learn, the better we can fine-tune these mechanisms for specific situations.
Which brings us back to that PFAS article and the whole idea of functionalization.
Oh, yeah, that's where things get really exciting.
I know, it's like giving biochar a custom upgrade.
Exactly. We can modify it to make it even better at targeting specific contaminants like those PFAS.
They mentioned a bunch of techniques, but I want to hear more about magnetization.
Ah, yes, the magnetic biochar.
The idea of just using a magnet to remove it seems almost too easy.
Well, it's all about those iron oxides.
Right, you add them to the biochar and boom, it becomes magnetic.
And then you can just pull it out after it's done its job, cleaning up those PFAS.
But how well does it actually work in the real world?
Really well, actually. Studies have shown that it's very effective at removing PFAS from contaminated water, and that magnetic separation makes the whole cleanup process so much faster and easier.
That's amazing. But I'm sure there are challenges too, right?
Of course, one challenge is making sure those iron oxides are spread evenly throughout the biochar.
Otherwise, some parts might be more magnetic than others.
Exactly. And you also have to make sure that magnetization doesn't mess with the biochar's ability to absorb those PFAS in the first place.
So it's a balancing act.
It is. But researchers are working on it, and I'm sure we'll see even more creative solutions in the future.
I'm excited to see what they come up with. And speaking of creative solutions, let's talk more about those biochar hydrogel composites.
Ah, yes, the dynamic duo.
Combining those two materials seems like such a smart move.
It is. They complement each other so well. Remember, we talked about how those composites have better absorption, are easier to handle, and are less likely to leach?
Right, all big advantages when you're trying to clean up real-world contamination.
Absolutely. So one really promising application is in cleaning up wastewater.
Oh, right, getting rid of all those pharmaceuticals and pesticides.
Exactly, all that stuff that can harm both people and the environment.
So these composites could help purify our water, making it safer to drink.
Exactly, and it goes beyond wastewater, too. Researchers are looking at using them for in situ remediation.
In situ, what's that?
It means cleaning up the contamination right where it is instead of having to dig everything up.
Oh, wow. So like injecting these composites into contaminated groundwater?
Exactly, they would capture those pollutants right there underground.
That's much more efficient and less disruptive than digging everything up.
Right, and because those composites don't leach as much, you don't have to worry about the contamination spreading.
So you're containing the problem.
Exactly, it's a win-win.
This is blowing my mind.
Yeah.
Biochar is going way beyond soil amendment now.
I know it's becoming this incredibly versatile tool for all sorts of environmental challenges.
And we're just getting started.
That's what's so exciting about it. Who knows what amazing applications we'll discover in the future?
All right, well, let's shift gears a bit and talk about some of the potential applications of biochar that go beyond environmental cleanup.
Sounds good. I'm ready for more biochar adventures. It really does seem like biochar can do it all, huh?
I know it's not just about cleaning up the environment either.
Right. Researchers are looking at using it for all sorts of things: building materials, energy storage, carbon capture.
It's mind-blowing.
Yeah, it's like biochar is finally getting the recognition it deserves.
It's having its moment.
Exactly. And one area I'm really excited about is construction.
Oh, how so?
Well, imagine using biochar in concrete to make buildings stronger and more sustainable.
How would that work?
Well, biochar acts like a reinforcement in the concrete.
Oh, interesting.
Yeah, those biochar particles actually bind with the cement and make the whole structure stronger.
So it's like adding tiny little pillars to support the building?
Exactly. And because biochar can actually remove carbon dioxide from the atmosphere during production,
Right.
using it in concrete could help us build buildings with a negative carbon footprint.
Wow, that's huge.
It could be a game changer for the construction industry, and then there's energy storage.
Oh, right. I remember reading something about that.
Yeah, researchers are looking at using biochar in supercapacitors and batteries.
Because of its porous structure.
Exactly. All those tiny pores make it perfect for storing energy.
It's like a tiny battery.
Right, and this could be a big deal for renewable energy.
Oh, how so?
Well, imagine using biochar supercapacitors to store energy from solar panels or wind turbines.
Uh-huh.
It could help smooth out those fluctuations in energy production, make the supply more reliable.
That would be incredible. And we haven't even talked about carbon capture yet.
Right, biochar is amazing at locking up carbon for a long, long time.
Hundreds of years even, right?
Exactly. So it's a powerful tool in the fight against climate change.
It's just mind-blowing to me that something as simple as charcoal can have such a huge impact.
It is pretty amazing. It just goes to show you the power of nature and human ingenuity.
It's a great reminder that sometimes the best solutions are right in front of us.
Exactly. And as we keep researching, I'm sure we'll find even more amazing ways to use biochar.
I can't wait to see what the future holds for biochar. It's such a fascinating and rapidly evolving field.
I know it's really inspiring to see all the amazing work being done.
It's a real testament to the power of collaboration and innovation. Bringing together researchers, scientists, entrepreneurs to tackle some of the world's biggest challenges.
It gives me hope for the
Well,
future.
on that note, I think we've covered a lot of ground in this deep dive into the world of biochar.
We have from project blueprints to PFAS removal to biochar-hydrogels and beyond.
It's clear that biochar is more than just a soil amendment. It's a versatile material with the potential to revolutionize industries and create a more sustainable future.
I think that's a great takeaway.
We hope you enjoyed this deep dive into the world of biochar. Be sure to check out Biochar Today for all the latest news and research.
And join us again next week for another exciting episode of This Week in Biochar.
Until then, keep exploring the amazing world of biochar.